Good afternoon, class. We are looking at chapter 7, trigonometric identities and equations. Here's 7.2, sum and difference formulas. So we looked at trigonometric equations and identities, and now sum and difference formulas. The objectives are: use sum and difference formulas to find exact values, use sum and difference formulas to establish identities, use sum and difference formulas involving inverse trig functions, solve trigonometric equations, linear in sine and cosine. So first, reminding everybody again of the unit circle and a point having coordinates x and y, x squared plus y squared is 1, x is cosine and y is sine, and the rest of them follow accordingly. Every trigonometric function is periodic with a period of 2 pi, except tangent and therefore cotangent. Every trigonometric function is odd, f of minus x equals minus f of x, except cosine. Therefore, secant also, they are even functions. Fundamental identities such as Pythagorean identities, quotient identities, reciprocal identities. And again, I remind you of even and odd properties here. As mentioned, all of them are odd except cosine and therefore secant. Now, here's the summary. Sum and difference formulas. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. We have to memorize these formulas. We need them. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. And tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. So we are going to look at the proof, and in this case, reminding you what we said in the previous page. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, and cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. This is the one we are going to prove. So we are going to look at a couple of angles. Consider two angles, alpha and beta. So we put them in a standard position. Here's the alpha, which is larger than beta. So if this is beta, then this point has p sub 1, has coordinates cosine beta, sine beta. And if this is alpha, then it has the coordinates, this point, p sub 2 has the coordinates cosine alpha, sine alpha. And this angle, as you can see, is alpha minus beta. Now, we try to put this difference in standard position. In other words, look at the same thing. We have this angle with the same value, alpha minus beta, in standard position. So this point A has coordinates 1, 0. This point, we're going to call it P sub 3, has coordinates cosine of alpha minus beta, comma, sine of alpha minus beta. Notice this chord covers the same distance. In other words, distance from A to P sub 3, this distance in green, is the distance from P sub 1 to P sub 2, right here. This is point P sub 1, this is point P sub 2. And we are going to use the distance formula to evaluate this. So Let's look at each one. And of course, since this is the top one, let's look at this distance. Remember the distance formula. Is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So in this case, would be cosine alpha minus cosine beta quantity squared plus sine alpha minus sine beta quantity squared under the radical. That would be the distance for the yellow piece, p sub 1, p sub 2. And for the green one, in the same manner, cosine of alpha minus beta minus 1 quantity squared plus sine of alpha minus beta minus 0 quantity squared under the radical. So if the two are the same, we're going to square both sides because it's easier to work with. So without the square root, also they are the same. And let me erase my work so I have enough room here. So left side is equal to the right side. Let's expand them. Cosine squared minus 2 cosine alpha cosine beta plus cosine squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Cosine of alpha minus beta, that means cosine squared of alpha minus beta, minus 2 cosine of alpha minus beta plus 1. And this one, this has no bearing, so simply sine squared alpha minus beta. So you square them. So what do we notice here? Cosine squared and sine squared, we want to put them next to each other because cosine squared alpha and sine squared alpha, they add up to 1. These two, cosine squared and sine squared beta, we can put them together because they also add up to 1. So on the left side, we are going to write these two together, and this one and this one. We take a common factor of -2, and we get -2 cosine alpha cosine beta sine alpha sine beta. On the right side, also we have cosine squared and sine squared of the same angle, alpha minus beta. It's important to know they are both the same. So we can put those two together. So we put those two together. We have number 1, and we have this one, -2 cosine of alpha minus beta. So what happens on the left side, this is 1, this is 1. So the left side is a 2. Let me just write it at top of it. What color do I want to use? So this is 1, this is 1. So the left side is 2, 1 and 1, 2 minus 2 cosine alpha cosine beta plus sine alpha sine beta. On the right side, this also, these two class add up to 1. 1 and 1, 2. So the right side is also 2, and whatever is left. So you can drop the 2 from both sides. Then you can divide both sides by -2. So you're left with cosine alpha cosine beta plus sine alpha sine beta equals cosine of alpha minus beta. And that's exactly what we have here. Believe it or not, that's the proof, and we are done. So we proved cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. But what about cosine of alpha plus beta? We are going to write cosine of alpha plus beta as cosine of alpha minus negative beta. And so cosine of alpha plus beta, we want to prove the first one. We're going to write it cosine of alpha minus beta. So in this formula, okay, we are going to replace the beta with minus beta. So this becomes cosine alpha cosine of minus beta. This becomes plus sine alpha sine of minus beta. Cosine is an even function, so cosine of minus beta or cosine of beta makes no difference. But sine is an odd function. Sine of minus beta is minus sine of beta. So you get cosine of alpha plus beta is cosine alpha cosine beta. So this one, just cosine beta. This one, change it with the negative, so minus sine alpha sine beta. And we proved this one as well. All right. Now, use the sum and difference formulas to find the exact values for cosine of 7 pi over 12. The idea is to notice you can cut this into two pieces, both of which are common arcs. And 7 pi over 12 is 3 pi over 12 and 4 pi over 12. This is pi over 4, this is pi over 3. By the way, if for any reason you can't see it, you can change it to degrees. It might be easier to see it that way. Cosine of alpha plus beta. Cosine alpha cosine beta. Cosine of power 4, cosine of power 3. Minus sine alpha sine beta minus sine of power 4, sine of power 3. And they're common arcs. So this is square root of 2 over 2. This is 1/2 minus square root of 2 over 2, square root of 3 over 2. And so all of them have the same denominator 4. So this is square root of 2. This is minus square root of 6. And that's the final answer, everybody. We're going to do the same thing with cosine of 15 degrees. Think of two common arcs that you know everything about them. 15 is the difference of, for example, 45 and 30 degrees. So cosine of alpha minus beta. Cosine alpha cosine beta, that means cosine 45 cosine 30, plus sine 45 sine 30. Cosine of 45 square root of 2 over 2. Cosine of 30 square root of 3 over 2. Sine 45 square root of 2 over 2. Sine 30 is 1/2. Again, they all have the same denominator, namely 4. What's the numerator here? Square root of 6 plus square root of 2. By the way, I just want you to notice cosine of pi over 12 is cosine of 15 degrees, meaning pi over 12 and 15 degrees are the same. So it's one of those common, I mean, in essence becomes common because you have 45 and 30, the information about it. So it's a good idea to be able to take care of the business this way. All right, sum and difference formulas are here. Cosine of power 2 minus theta is sine theta. Sine of power 2 minus theta is cosine theta. We want to look at the proof, and we've seen this before. As far as the graph is concerned, if you want to use the graphing calculator to prove it, just the type of proof, you can graph the left and the right side. So y1 is the left side, cosine of power 2 minus x. y2 is the right side, sine x or sine theta. It doesn't matter what variable you use. And you graph the two as y1 and y2, and you notice that you just get one graph, and that's a proof that it's the same thing. However, we can also use cosine of alpha minus beta, which is cosine alpha cosine beta plus sine alpha sine beta. So cosine of power 2 cosine theta plus sine of power 2 sine theta. That's the proof analytically. And cosine of power 2 we should know is 0, sine of power 2 we should know it's 1. Obviously, this becomes 0 and this becomes sine theta. And that's the proof that cosine of power 2 minus theta is sine theta. For number 2, sine of power 2 minus theta, we are going to manipulate what we have already proved. So we're going to play with this and write cosine theta as cosine of power 2 minus theta. Let me just show you what you get, and I'm going to erase that. What color do I want to use? Okay. Notice inside the bracket is pi over 2 minus pi over 2 plus theta. Please understand the bracket is simply the entire bracket is cosine theta. So what we are saying, cosine theta equals cosine theta. So it's just playing with the format by which we write pi over 2 minus theta. So we know this bracket also is the same as theta, and therefore cosine theta is equal to cosine theta. You don't have to prove anything. Let me erase my work. And so if we let x represent the parentheses power 2 minus theta, so this is x, everybody. Okay. So we are looking at this one. So this is x. So we are looking at cosine of pi over 2 minus x. What is cosine of pi over 2 minus theta? Sine theta. What is cosine of pi over 2 minus x? Sine x. On the one hand. On the other hand, sine x, we said x is pi over 2 minus theta, so it's equal to sine pi over 2 minus theta. And of course, we know it's cosine theta. So therefore, sine of pi over 2 minus theta equals cosine theta. Believe it or not, that's the proof for number 2. So it's a pretty straightforward. When you want to prove anything, you start with something that you've already proved. So this is the methodology that is used for proving identities. Now, we actually want to go back. We proved cosine of alpha plus beta and cosine of alpha minus beta are what they are. And we want to prove sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. We want to do that, and we want to use the fact that cosine of power 2 minus theta is sine over 2 sine of power 2 minus theta plus cosine. But by the way, the idea is that the two angles, theta and power 2, are complementary, add up to 90 degrees. And you recall from a right triangle that the sine of one side is cosine of the other one, right? Of course, we're talking about acute angles. So let's start with this. Cosine of power 2 minus theta. Instead of theta, we're going to use alpha plus beta. So let theta be alpha plus beta. So we're going to replace this with alpha plus beta. So cosine of power 2 minus theta, or cosine of power 2 minus alpha plus beta. If this is sine theta, this must be sine theta also, or sine of alpha plus beta, because we are replacing theta with alpha plus beta. Both of them are theta, right, class? Now we're going to manipulate the brackets as power 2 minus alpha and then minus beta. First, take a look at the brackets. Nothing has changed. Pi over 2 minus alpha minus beta. And now we are going to look at the concept of cosine alpha minus beta. So think about this as alpha. Cosine of this minus beta, right? So cosine alpha, cosine beta plus sine alpha, sine beta, following this formula, everybody, following this formula. We get cosine of this, cosine of beta, plus sine of this, sine of beta. So cosine of pi over 2 minus alpha, cosine beta, plus sine of pi over 2 minus alpha, sine beta. What is cosine of pi over 2 minus alpha? According to this, cosine of pi over 2 minus theta is sine theta, so this must be sine alpha. What is sine of pi over 2 minus alpha? According to this, sine of pi over 2 minus theta must be cosine theta, so this must be sine. Sine of pi over 2 minus alpha must be cosine alpha. And believe it or not, we just proved sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. What about sine of alpha minus beta? Well, since we have proved this, we're going to write this, okay, in the following manner. Replace it with negative beta. So plus negative beta. So sine of alpha minus beta is sine of alpha plus negative beta. So into this formula, alpha is alpha, replace the beta with negative beta. So sine of alpha minus beta is sine of alpha plus minus negative beta. Sine alpha cosine minus beta, cosine alpha sine minus beta. As you know, sine is odd, cosine is even. Therefore, cosine of minus beta is the same as cosine of beta. So sine alpha cosine beta. But sine of minus beta is minus sine beta. So again, just so this is the same as cosine beta. This is the same as negative sine beta. And that proves sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Use the sum and difference formula to find the exact value in the case of sine 19 pi over 12. Again, if it makes it easier, just go with the degree so you can put them together in that manner. This is 16 pi and 3 pi, both of them over 12. This is 4 pi over 3. This is pi over 4, both of which are common arcs. All right, so sine of 4 pi 3 cosine of pi over 4 plus cosine of 4 pi 3 sine of pi over 4 according to sine of alpha plus beta formula. Well, let's simplify. Common arcs. Sine of 4 pi over 3 is the same as sine of pi over 3. In this, as far as the value is concerned, which is square root of 3 over 2. In the third quadrant is negative, so minus square root of 3 over 2. Pi over 4 cosine is square root of 2 over 2. Cosine of 4 pi over 3 is also the same as cosine of pi over 3, but negative in the third quadrant. So it's 1/2 negative minus 1/2. This is square root of 2 over 2. Again, common arcs. As you can see, again, the denominator is 4 for all of them. This is minus square root of 6 minus square root of 2. That's the final answer, everybody. We want to find the exact value for cosine 40, cosine 80 minus sine 40, sine 80. So cosine alpha, cosine beta minus sine alpha, sine beta. It's cosine of alpha plus beta, cosine of 40 plus 80, which is cosine of 120 degrees, which is the same as cosine of 60 degrees, but negative in this second quadrant. So cosine of 120, reference arc is 60 degrees. Okay, 180 minus 120. So it's the same as cosine of 60, which is 1/2. However, positive or negative depends on the quadrant. In the second quadrant, cosine is negative. Sine of 80 cosine of 20 minus cosine of 80 sine of 20. So we recognize this one as sine of alpha minus beta. So this is sine of 80 minus 20, which is sine of 60, common arc, square root of 3/2. Okay, we are going to move on and see what's going on here. Given sine alpha is 4/5, and alpha is between pi/2 and pi, second quadrant, and sine of beta is negative 2/square root of 5 or negative 2 square root of 5/5, and beta is between pi and 3 pi/2. Find the exact value for cosine alpha, cosine beta, cosine of alpha plus beta, sine of alpha plus beta. So that's what we are going to look at, everybody. And so there are different ways of approaching it. You can go with sine being y/r, and we are dealing with quadrant 2 in quadrant 2. Y is positive. Of course, R is always positive. R is 5, Y is positive, but X becomes negative. So Y is 4, R is 5. We are dealing with quadrant 2. We are dealing with this shape. X comma R, this is 5. X squared plus Y squared is R squared. In other words, X squared plus Y squared is 25. And X becomes negative 3 because remember, Y squared is 4 squared or 16. And so there's a different color here. So X squared becomes 25 minus 16, which is 9. So there are two answers for X, positive or negative 3. However, in the second quadrant, we should know it's negative. So cosine alpha is x/r, makes it negative 3/5. So that's one way to do it. This is using circles. Or we can use identity, sine squared plus cosine squared equals 1. which makes cosine alpha plus minus the square root of 1 minus sine squared. So plus minus the square root of 1 minus 4 over 5 quantity squared. And this is 16 over, let's just write it here. So this is 16 over 25. 1, you write that's 25 over 25. You get 9 over 25 comes out as 3 over 5 plus minus. Now, which one do you choose, positive or negative? In quadrant 2, cosine is negative. So, what is my point? You have a choice of using circles or using identities. Makes no difference. I did both for just practice in essence. What about sine beta is negative and it's in the, they are given the third quadrant. We're not going to go with both methods. Let's go with one of them. Let's go with identities. If you're given sine, cosine is plus minus the square root of 1 minus sine squared. So plus minus 1 minus sine squared. So minus square root of minus 2 over square root of 5 quantity squared. And I hope you see that we get this one is 4 over 5. So 1 minus 4 over 5 is 1 over 5. So we get plus minus square root of that, or plus minus 1 over square root of 5. Now, we are in the third quadrant. Third quadrant. Sine is negative. So is cosine. So you choose the negative one. Let me erase my work. You choose the negative one, and if you multiply the top and the bottom by square root of 5, to rationalize it becomes negative square root of 5 over 5. Let me just quickly show you. So times. So let's write what we have. Okay, sine of alpha was 4 over 5, and we found cosine to be negative 3 over 5. Sine of beta was negative 2, either over square root of 5 or negative 2 square root of 5 over 5 rationalized, and we found cosine beta. So this is the summary of what we've done, and now we are ready to move on to the next one. Cosine of alpha plus beta, it's cosine alpha, cosine beta minus sine alpha sine beta. So plug in cosine alpha negative 3 over 5, cosine beta minus square root of 5 over 5, minus sine alpha 4 over 5, sine beta negative 2 square root of 5 over 5. So just plug in and evaluate. So I hope you recognize the denominator as 25 for everything. So minus 3 minus square root of 5 is, see, what color can I use here? So this becomes 3 square root of 5. Minus minus becomes 8 positive square root of 5. So I hope you see that you have 11 square root of 5 in the numerator, and the denominator is 25. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta using the formula that we have here. And we just plug in. Sine of alpha is 4 over 5. Cosine beta is minus square root of 5 over 5. Cosine alpha is negative 3 over square root of 5, and sine beta is negative 2 square root of 5 over 5. So what do we have here? 4 of them. The denominator is 25 in both cases. So now let's go with this color. We have minus 4 square root of 5. Over here we have plus 6 square root of 5. With minus 4 square root of 5 is 2 square root of 5. So that's pretty straightforward. We want to establish identities. In this case, cosine of power 2 plus theta equals negative sine theta. We're going to start with one side. The left-hand side is more complicated. Let's start with that. Cosine of alpha plus beta. Cosine alpha cosine beta minus sine alpha sine beta. That means cosine of power 2 cosine theta minus sine power 2 sine theta. Cosine of power 2 is 0. Sine of power 2 is 1. So this goes to 0. This becomes negative sine theta, and that's the proof. We want to prove cosine of pi plus theta is minus cosine theta. Again, we start with the more complicated side, namely the left LHS, the left-hand side. Same thing here, cosine of alpha plus beta. That's what we are going to use. Maybe I put the asterisk next to it. This is what we are using, okay, in both cases. So cosine pi cosine theta minus sine pi sine theta, and those are common arcs. Cosine of pi is -1, whereas sine of pi is 0. So this goes to 0. This is negative cosine theta, and that's the final answer. All right, we said tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta, and tan of alpha minus beta just basically change the sign. So we want to prove the sum and difference formulas for tangent function. Well, as you know, tangent is basically sine over cosine. Therefore, tan of alpha plus beta is sine of alpha plus beta over cosine of alpha plus beta. So you put this one over this one. Now notice we see number 1 here. So we have a plus sign is good, minus sign is good. So this actually gives you the trick that requires finishing the job. Divide by this piece, everybody. Divide everything by this piece if you want to get 1. So make up 2 fractions at top. So in other words, you're dividing the top and the bottom by what I mentioned. Make up 2 fractions at top, 2 fractions at the bottom. So what happens? Let me look at this. Cosine beta. Cosine beta. Cosine beta cancel each other. Sine over cosine alpha, this is tan alpha. Cosine alpha cancel each other. Tan beta. And this is 1. This is sine over cosine, tan of alpha. This is sine of beta over cosine beta, tan of beta. And believe it or not, that is the end of the proof. Now for alpha minus, when you prove one of them, the other one, just change the b to minus b. So write down plus minus b. Replace the beta with minus beta in tan of alpha plus beta to prove tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta, because it's an odd function. So if you replace this one with a negative, this becomes negative. This becomes negative times negative is positive. I'm going to leave it for you to finish that, but that's all you have to do. It's very straightforward, everybody. We want to establish the identity tan of 2 pi minus theta is negative tan theta. So we're going to go with tan of alpha minus beta. We're going to start with the left-hand side. We're going to, and we're going to go with this one. This is tan alpha minus tan beta over 1 plus tan alpha tan beta. So we have tan of 2 pi minus tan of theta over 1 plus tan of 2 pi tan of theta, according to tan of alpha minus beta formula. Everybody knows tan of 2 pi is 0, so replace it. So the numerator is negative tan theta. The denominator is 1, so this is 0, so you're looking at negative tan theta over positive 1, which is negative tan theta, and that's the proof, everybody. Cosine of alpha minus beta over sine alpha sine beta is cotangent alpha cotangent beta plus 1. So we start from one side. We're going to start with the left-hand side. The denominator is what? The denominator is cosine of alpha minus beta is used here. Cosine alpha, cosine beta plus sine alpha, sine beta. And I hope you can see that we can make up 1 and 2 fractions. So cosine alpha over sine alpha is cotangent alpha. Cosine beta over sine beta is cotangent beta. And this, the top and the bottom are identical. It's just 1. So cotangent alpha, cotangent beta plus 1. Tan of theta plus pi over 2 is negative cotangent theta. And we start with the left-hand side. It's more complicated again. LHS, the left-hand side. And tan of alpha plus beta in essence, or we can write sine over cosine. We can go either way. So if we go with the sine over cosine, everybody, that means sine of theta plus pi over 2 over cosine of theta plus pi over 2. Okay, let's look at the top one, sine of alpha plus beta. Sine theta, cosine pi over 2 plus cosine theta, sine pi over 2. That would be the top. Cosine of theta plus pi over 2. This one. Cosine theta, cosine pi over 2 minus sine theta, sine pi over 2. So let's do this. Plug in. Okay. Cosine of power 2 is 0. Sine of power 2 is 1. So let's plug in. So what happens is to go to 0. So the numerator is cosine, the denominator is negative sine. Everybody, cosine theta over negative sine theta, which is negative cotangent theta. Negative cotangent theta. Cosine of alpha plus beta over cosine of alpha minus beta is 1 minus tan alpha tan beta over 1 plus tan alpha tan beta. There are two ways to do that. Is one of them is to start from one side. I'm going to start with the left-hand side. The second one, you could do the cross product, everybody. In other words, show that these two are identical. You can work on that. Sometimes might be easier. In some instances, they may not like it that you go that route, but that is a correct methodology as well. So starting from the left side, we just are going to go with cosine of alpha plus beta in the numerator and cosine of alpha minus beta, you put that in the denominator. So cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta plus sine alpha sine beta. Now again, let me erase my work. Now, what is the next step? And here's the trick that will do the job. If you look at this number is 1, this number is 1, the negative sign is there, the positive sign. How do you make this one or this one 1? If you divide everything by this piece, makes this one 1, makes this one 1. So you try it. That is the technique, that is the trick. Divide by something that will give you what you want here. Look for the number. So divide by cosine alpha, cosine beta. So you have 1, 2, 3, 4 pieces. You're going to divide everything by cosine alpha, cosine beta, and simplify. Clearly, these two are identical, so each one is 1. So these two are very easy. They are 1. Let's write the other piece in the following manner to make it easy to see. So we're going to write this one is 1, this one is 1, and we're going to write this one. Sine over cosine, same thing, alpha. In this case, sine over cosine, same thing, beta. And we do the same thing here. Obviously, this is tan of alpha, whereas this one is tan of beta. And so the final answer is 1 minus tan alpha tan beta over 1 plus tan alpha tan beta. And that's the idea.
$300 something. You caught that, bro? 300. Sorry, but it's
Wow, what can I say? Cosine of cosine inverse of 2/3 plus sine inverse of negative 3/4. What is important to understand, each inverse represents an arc or angle, let's say X or Y or Z or alpha or beta. So therefore, you're going to say cosine of this represents, this is alpha, this is beta. This is one way to handle it. So you're looking at cosine of alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. So what does that mean? Cosine alpha must be 2/3. And because cosine is positive, it's in the first quadrant. What does that mean? Sine of beta must be negative 3/4. And since sine inverse, the restriction was the fourth and the first quadrant, this must be in the fourth quadrant. So sine beta is negative 3/4, where beta is between negative power 2 and 0. So going back to cosine of alpha minus beta, we need cosine alpha cosine beta, sine alpha sine beta, and we have cosine alpha. We need to find sine alpha, we have sine beta, we need to find cosine beta, and we go with either the identity or the circums. Identity makes more sense. Sine squared plus cosine squared equals 1. Sine of alpha is plus minus the square root of 1 minus cosine squared, and it's positive because we're talking about the first quadrant. So 1 sine of alpha is positive, okay? And so 1 minus 2/3 quantity squared. This is 4/9. 1 minus that is 5/9. Comes out as square root of 5. Comes out as 3. So it's square root of 5/3. We do the same thing for sine beta. We say sine squared and cosine squared, they add up to 1. That means cosine is either positive or negative 1 minus sine squared beta. We said this is the fourth quadrant and cosine is positive. So you choose the positive one and you replace the sine of beta with negative 3/4. So this is 9/16. 1 minus that is 7/16. 7 remains, 16 comes out as 4. So we are going to use cosine of alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta. Let's summarize what we have. Sine of alpha is square root of 5/3. Cosine of alpha is 2/3. Sine of beta is negative 3/4. Cosine of beta is square root of 7/4. Plug in. Plug in. So what happens when we plug in everybody? They all have the same denominator, 12. So fraction bar 12. What's at top? 2 square root of 7 minus and minus plus 3 square root of 5. And that's the final answer, everybody. We want to prove secant of alpha minus beta is secant alpha secant beta over 1 plus tan alpha tan beta. And what we are going to do, we are going to start with one side. In this case, you can start with any side you want. I'm going to actually look at both cases. So let's start with LHS, the left-hand side, secant of alpha minus beta. And you know secant is 1 over cosine. So secant is 1 over cosine. 1 over cosine of what? Alpha minus beta. So 1 over cosine of alpha minus beta, put this one here, which becomes cosine alpha cosine beta plus sine alpha sine beta. Again, perhaps this will help. You want this become 1, you want to change this to 1. That would do the trick. How do you change this to 1? Divide by itself. So you're going to divide everything by cosine alpha, cosine beta. Right? And separate them. So this is 1 over cosine alpha, 1 over cosine beta, and then cosine alpha, cosine beta over this, sine alpha, sine beta over this. So cut them into pieces. Now, what is this? 1 over cosine alpha is secant alpha. What is this? 1 over cosine beta is secant beta. So we got the numerator. What is this? Everything cancels out. 1. Sine over cosine, that gives you tan alpha. Sine over cosine gives you tan beta. So believe it or not, that's the proof, and you're done. But I quickly show you the second method. In this case, you could start with the right-hand side because one may be under the assumption that the right-hand side is more complicated, in which case we're going to write, since it's secant, we're going to change everything to cosine and sine. So secant, 1 over cosine alpha, 1 over cosine beta, tangent, sine alpha over cosine alpha. This one, sine beta over cosine beta. You're dealing with a complex fraction, everybody. In order to make it into a simple fraction, you're going to multiply by LCD, and notice this has cosine alpha, cosine beta. This has cosine alpha, cosine beta also, and therefore the LCD is cosine alpha, cosine beta. So you're going to multiply everything, the top and the bottom, by cosine alpha, cosine beta. So what happens? First of all, when you multiply this one, everything cancels out the denominator, so you get 1. When you multiply this one by this one, you get cosine alpha, cosine beta. When you multiply by this one, this goes away, you get sine of alpha, sine beta. Please check this out. Make sure you can handle the complex fraction. So when you multiply these two, the numerator becomes 1. Multiply these two, you get this one. And multiply these two cancel each other. One over cosine alpha, cosine beta plus sine alpha, sine beta. As you know, it's cosine of alpha minus beta. If it's 1 over cosine of alpha minus beta, it's the same as secant of alpha minus beta. That's the proof. And you may find this a tad easier.